Hi, welcome to my video on more solving polynomial equations. And as in the previous videos, we were dealing with the equation A, x to the n, b, x to the n minus 1, c, x to the n minus 2, etc. to a constant of k equals 0. The coefficient of the integers coefficients are integers, and n power is belonging to the whole number, so it goes down descending power. So before we dealt in the previous video before this one, two back, we were dealing with a is equal to 1, but in this video a can be any integer at all. It could be a 1, could be a 2, 3, -4, whatever you wish. But all the coefficients are integers. And the steps for solving the equation, this equation, is we're going to put the terms to the left equal to 0, descending order, number of roots. GCF of x is 1 a root. Sum of the coefficients is 0. Grouping of the terms if there's 4 unlike terms. And if none of this works, then we'll use synthetic division. We'll find all possible roots. And in this case, because a could be 1 or not 1, there'll be rational roots or fractions and integers. We'll use Descartes' rule to find if the signs are positive, negative, and possible imaginary roots. We use synthetic division to find a root when the remainder is 0. We keep doing the synthetic division on the depressed equation to find another root when r is 0, and repeat until the depressed equation becomes quadratic. And then we'll solve the quadratic by factoring, completing the square or quadratic formula. Normally I do, if I can, I'll factor if I can. If I can't, I'll use the quadratic formula. And a tip, when the first rule is found by synthetic division, check that that root is there again. And it could be a double root or sometimes even a triple root. Here we go. Find the roots of x cubed plus 2x squared plus 9 equals 0. And we're going to follow the pattern that I've established. Is it equal to 0? Yes. All terms are on the left. Is it in descending order? Yes. 3, 2. Notice the x to the 0 is missing. And then a constant. And the number of roots, the highest degree is 3, so we have 3 possible roots. And I always check, is x common? No. GCF of x is 0 a root. To add up the coefficients, 9, 2, and 1 adds up to 12. 0 is not a root. And can we group them with 4 terms? Nope. So we're going to use synthetic division. So when we use synthetic division, we check the possible roots, and the roots p is 9. So that means we have plus minus 1, 3, and 9. And q is 1, which is right here. So we have plus minus 1. So the p over q is plus minus the factors of p, which is 1, 3, and 9, divided by, I'll add down, divided by the factors of 1. So that gives us plus minus 1 divided by 1 is 1, 3 divided by 1 is 3, and 9 divided by 1 is 9. So notice when we have a 1 here, we just only need to look at the factors of 9. And we don't have to go through this. I went through it to show you. Dividing by 1 gives you the same factors of 9. Now we want to look at the positive, the negative, imaginary roots, the numbers, and the total. Now we know that the total number of roots is always going to be 3. So we check here. So that's positive, positive, positive. So the number of positive roots is 0 because there's no change in the sign. And let's look at the negative. So if we look at the number of negative roots, we put a negative here, negative x cubed is negative, negative x squared is positive, so positive 2 times a positive is a positive, and a positive 9, so we have one change. So there's one change, so we have one negative root. There are 3 roots, so we have no positives, 1 negative, so we must have 2 imaginaries. So we have 1 negative root. So remember that 1 is not a root, so we have to check with to see if 3 is a negative root. So we have a negative root. We have no positives, so the negative root would be a negative 1. So synthetic division is 1, 2. Notice the 0 has to go in here. We're doing synthetic division. Got to put the 1, 3, 2. That's a 1 power, and that's a constant. So 1, 2, 0, 9. Draw a line. Bring down your 1. Multiply. Negative 1. Add. 1. Multiply. Negative 1. Add. Negative 1 multiply 1, and we get a 10. So the remainder is not 0, so negative 1 is not a root. Now we'll try a negative 3 into 1, 2, 0, 9. Draw a line, bring down your 1. Multiply. Negative 3. Add. Negative 1. Multiply. 3. Add 3. Multiply. Negative 9. 0. Oh, we have a 0 remainder. That means negative 3 is a root. That means my depressed equation is x squared minus x plus 3. Remember, that's a cube. So that's x cubed, x squared, x constant. So it goes down by 1, so the x cubed becomes an x squared. So x squared, x constant. And now we have a quadratic. What factors of 3 will give us a negative 1? Well, we got to do the quadratic formula. So a is 1, b is negative 1, c is 3. So x equals negative b plus or minus b squared minus 4ac all over 2a. b is negative 1, so it's the negative of a negative 1 plus or minus b squared is negative 1 squared minus 4. A is 1. C is 3. All over 2 times A, which is 1. So that gives us negative is a positive. And we'll work this out up here so we don't have to keep writing it down. Negative 1 squared is 1. And negative 4 times 1 times 3 is negative 12. That's a negative 11. So that becomes root 11i. Root 11i all over 2. So the root is 1 divided by 2 plus or minus root 11 over 2i. And we have 3 roots, so the roots are, we found that negative 3 was a root. So we have 1 plus root 11 over 2i, and we have 1 minus root 11 over 2i. So that's the 3 roots. Okay, don't forget you can pause your video at any time and work these out yourself. That's a good way to check to see if you know what you're doing. And here we go here. Find the roots of this equation. Notice we had to check, follow the order. Are all the variables or terms on the left side? Yes, equal to 0. Are they in descending order? 5, 4, 3, 2. Perfect. And the number of roots here, x to the 5 is the highest, so we have 5 roots. Now, I check to see if x is common. Do we have x in every term? Yes, so I take out the x, the smallest exponent of 5, 4, 3, 2. 2 is the smallest exponent. So we divide x squared into both of these. We get 2x cubed minus x squared minus 7x plus 6 equals 0. So we have x squared equals 0, and we have 2x cubed minus x squared minus 7x plus 6 equals 0. If x squared equals 0, then notice x, the square root of x squared, is the square root of 0. So x is equal to 0. But notice that x squared, just note, the x squared is really x times x. So really, if you think about it, 0 is a root, but there's 2 of them because there's 5 altogether. So there is a root of 0 that'll make this equation equal to 0, but there's 2 of them here, just want to emphasize. Now we're looking at this equation, which is a cubic. And the thing that we check after that is, do they add up to 1? Or sorry, add up to 0. 2 plus 6 is 8. Negative 1, negative 7 is negative 8. Adds up to 0. So 1 is going to be a root. So we get 2 and 3, 2, 1, 0. So they're all there. So that's negative 1, negative 7, 6. Draw a line, bring down your 2. 1 times 2 is 2. Add 1. Multiply 1. Add negative 6. Multiply negative 6. Add 0. Oh, we got, because the coefficients added up to 0, I knew 1 was going to be a root. So that means we have 2x squared plus x minus 6 equals 0. Again, that's a cube, so this is an x squared. We bring it down 1. So x squared, x constant. And we can do this 2 ways, by factoring, or we can do the quadratic formula, whatever way you want to do it. Okay, well, let's see if we can factor it for a bit of practice. The product is a times c, which is 2 times negative 6. So the product is negative 12, and the sum is 1 in the middle. Sum is b, so the sum is 1. So what are the factors of 12? Factors of 12 are 1 times 12, 2 times 6, 3 times 4. So notice the product is negative 12. So we got 2 factors that multiply to give you negative 12 and add to give you 1. So it looks like it's 12 and 1 won't do it. 2 and 6, so it's 3 and 4. So we take the 3 and the 4. Now, it has to be, has to multiply to give you negative 12. So let's see, and add to give you 1. So that's a negative 3 and a plus 4. So a minus 3x plus 4x minus 6 equals 0. Again, check. Notice I put negative 3 and 4 here. Multiply negative 3 by 4. You get a negative 12, and add, and you'll get a 1. And the product, when this is not 1, the product is a times c, which is negative 12. So we take out the x because we have 4 terms. X is the common, so it's 2x minus 3. And we take out a plus, and 2 is common, so we take out a plus 2. We get 2x minus 3. Looks good because 2x minus 3 is common. And what's left is x plus 2. So we got 2x minus 3 is equal to 0. Or we got x plus 2 is equal to 0. 2x equals 3. Move it over, make it, and divide by 2. So x is equal to 3 over 2. And here x is equal to negative 2. So the roots, to sum it all up, the roots are, you could say 0, but there's 2 of them. And right here we got a 0, so 1 is a root. And right here we have 3 over 2 and negative 2. So there's 5 roots. Again, 0 is here twice. So there's 0, 1, root, or 3 over 2 and a negative 2. But you got to have 5 roots, so there's 2 zeros. So I've used my pattern consistently. If I follow the pattern, I'm consistently doing right. That's the way I do it. Find the roots of this one. And again, we have 5 roots because the highest degree is 5. Okay. And we have everything on the left equal to 0. True. It's in descending order. 5, 4, 3, 2. Oh, again, notice x to the 0 is missing. Or sorry, 0, and not x to the 0. The x coefficient, the x, what I say, literal coefficient is missing to the power of 1, so 0 is here. So we have x is not common to all the terms. Do the coefficients add up to be 1? That's a 12 and a negative 12. Yes, they add up to be 0. So if you add the negatives up and the positive up, you get 0. So that's a 2, -3, -6, 10. And we have to put that 0 in there when we're going down in descending order. And 3. Draw a line. Now I know because they add up to 0, I know 1 is a root. So that's a 2. Bring down your 2, multiply. 2, add, -1. Multiply, -1, add, -7. Multiply, -7, add, 3. Multiply, 3, add, 3. Multiply, 3, add, 0. So I knew that I was going to get a 0 remainder. So I check again to see if 1 is a root again, because sometimes they have a double. So add them up. -8, 2, 3, 3 is 8. Again, 1 is a root, so it's a double root of 1. So the depressed equation is 2, -1, -7, 3, 3. I don't have, remember, that's x to the 5th. So this is x to the 4, x cubed, x squared, x constant. So there it is. Draw a line, bring down your 2, multiply, 2, add, 1, multiply, 1, add, -6, multiply, -6, add, -3, multiply, -3, and we add, and because the coefficients added up to 0, 1 was going to be a root. So now we have 2, depressed equation is, that's 5, so that's 4, so that's a 3, so that's 2x cubed plus x squared minus 6x minus 3. So now we got to check on this equation. So if you want to write that equation down like that, and that's a square, that's an x, and that's a constant equal to 0. So now we got 3 roots. So there's 5 roots altogether, but we already found 2. So now on this equation, there's only 3 roots left to find. So what are the possible roots? Well, the possible roots are the factors of p and the factors of q. So p is -3, q is 2. So the possible factors are plus minus 1 and 3. For 2 is plus minus 1 and 2. So p over q is plus minus. It's the factors of 1 and 3 divided by the factors of 1 and 2. So that's going to give us, divide 1 into both of these. 1 divided by 1 is 1. 3 divided by 1 is 3. 1 divided by 2 is a half. And 3 divided by 2 is 3 over 2. So there's all the possible factors. Plus or minus 1, plus or minus 3, plus or minus a half, plus or minus 3 over 2. Now we also have to look at picking up what we call Descartes' rule. So we got a plus, minus, imaginaries, total. And when we look at this, we have no change, 1 change, no change. So there's only 1 change in this equation. So there's 1 positive. So when we put a negative in here, if we put negative x cubed, that's a negative. We put a negative x squared, it's going to be a positive. -6 times negative x is a positive and a negative. So we got 1 change, 2 changes. So it's 2, or that's for the negative roots. There's 2 or 0 changes. So it's possible 2 or 0 negative roots. So there's 2 negative roots. And also we got 0 negative roots. So that means there's no imaginaries because there's 3 roots. And you got 1 positive. And we got 0, so that's 2 imaginaries, total of 3 roots. So that just helps us. We know we have, from this equation, 1 positive. So you got a choice. If they're imaginary roots, you can't find them. So either you got 1 positive or 2 negatives. But if they're these, you can't find them. So let's go for the positive root. So what I'm going to do is check. We know 1, we check the possible roots are, 1 is not a root because they don't add up to 0. So I'm going to check with the 3. So 3 and 2. And I'm going to check 2, 1, negative 6, negative 3. Bring down to 2. I get a 6, 7, 21, 15, 45. No. Now I'm going to check if we got 1 and 3 apart. Now I'm going to check with a half. So this is, as you can see, trial and error. And we really don't know what it's going to be. So bring down to 2. Half of 2 is 1. Add, you get 2. Half of 2 is 1. Add, you get a negative 5. Half of 5 is negative 2.5. No. So now we got to check with 3 over 2. So again, it's a game that you play, and you got to check very quickly. And you bring down to 2. 3 over 2 times 2 is 3. That's a 4. 3 over 2 times 4, 2 into 4 goes 2. That gives us a 6. That gives us a 0. You multiply, you get a 0. And the remainder is negative 3. So 3 over 2 is not working. So we tried 1 is not a root of this equation. We tried 3. We tried a half. We tried 3 over 2. So we must have a negative root. But the negative roots are not these. So that means if they're not these here positive, then it must be a positive irrational root that we can't find yet. So we got to check with the negatives now. So let's check with the negative 1. So we check with negative 1 with synthetic division on 2, 1, negative 6, negative 3. Bring down to 2, multiply, negative 2. Add negative 1, multiply 1, negative 5, multiply 5. Nope. So 1 is not going to do it. So let's try the 3. And let's see, the odds are we should be hitting it pretty soon. So it's 2, 1, negative 6, negative 3. So bring down your 2. Negative 3 times 2 is negative 6. Gives me negative 5. Okay. Negative 3. That's a 15. And that adds, it gives me 9. That gives me, nope. So we haven't found it so far. So it's not a 1. Negative 1 is not negative 3. So how about negative a half? Imagine now you got to go through all this. And the faster you can do your synthetic division, that's why it's good to look at all possibles. And you don't know what the teacher's going to make up, how hard it's going to be. So we bring down to 2. Negative a half times 2 is negative 1. 0 when you add. 0. Add negative 6. Negative a half times negative 6 is a 3. Oh, we found one. Finally, we found one. So negative a half is a root. Now we have a depressed equation called 2x squared plus 0x minus 6 equals 0. Depressed equation is quadratic, so that's 2x squared minus 6 equals 0. I put the 0 in here. I didn't have to. I could have just wrote that. So 2x squared equals 6 divided by 2. X squared equals 3. The square root of x squared is plus minus the square root of 3. So x is plus minus 3. So look at all the synthetic division. I tried them all. And notice we're working on depressed equations. So the roots are, notice now we had a 1 and a 1, double. And we worked here with a negative a half. And we have, plus or minus the root 3. Plus root 3 minus root 3. So that's your 5 roots. Good question. I had to do all this synthetic division. And notice that the positive and negatives, when you do your Descartes rule here, it narrows it down. You only have one positive left. So I was looking for the positive, but they weren't there. So then I had to go look for the negatives. And I didn't know if there's going to be imaginary roots or not. But these are irrational. They're not imaginaries. They're real roots. So that's positive, positive, positive. So this one is negative. And that's a negative root 3. So that's about a negative 1.7. So they are real. Okay, number 4. Find the roots of this equation. Okay, here we go. I'm a pattern. Equal to 0, all terms on the left side in descending order, 4, 3, 2, 1, perfect. Now there are 4 roots because the highest degree is 4. And there's no x common, no GCF. Do the coefficients add up to 0? Well, we have, let's see, negative 52, so that's negative 17. So that's a negative 69, and 50, so we have a positive 66. Nope, 1 is not a root, and it can't be grouping because there's 5 terms here. So now we have to go after values of p, values of q. So p is 2, q is 16. So the possible value or factors of x are 1 and 2, and the possible factors of 16 are 1, and 16 is 1 times 16, 2 times 8, 4 times 4. So it's 1, 2, 4, 8, 16 if you want to do them in order. So p divided by q is plus or minus the factors of 2 divided by the factors of 16, which is 1, 2, 4, 8, 16. So let's take our time and do plus minus, and let's do that division. So 2 and 1 divided by 1 is 1 and 2. 1 and 2 divided by 2, 1 divided by 2 is a half. 2 divided by 2 is 1 already there. Let's divide by 4. 1 divided by 4 is a quarter. 2 divided by 4 is a half, already there. Divide by 8. 1 divided by 8 is 1 over 8. 2 divided by 8 is 1 quarter, already there. And now I divide by 16, so I get 1/16. 2 divided by 16 is 1/8, already there. So these are all possible, plus or minus each one of these. So now we have to look at Descartes' rule, plus, minus, imaginaries, total. So here's the equation up here. So 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes. So there's 4 or 2 or 0. So there's 4 changes, so we go down by 2. So it's a 4, a 2, or a 0. Now let's check the negatives. Let's check the negatives. Put a negative right here. Negative x to the 4th power is positive. Negative x to the 3rd power is negative, and negative makes a positive. Put negative x squared, negative x and squared here, we get a positive, so that becomes a positive. Put a negative x here, becomes negatives. Negative times a negative is a positive. And we have a positive 2. So notice for the negatives, I just wrote negative, I can't spell negative now. That's the negatives, we have no changes. No change. So we have 0 negative for each one of these. So if you have 4 positives, remember there's 4 roots, we have no imaginaries because there's 4 roots. If we have 2 positives, no negatives, we have 2 imaginaries because we have 4 roots. If we have no positives, no negatives, we have 4 imaginary roots. Total is always 4. But if you got 4 imaginary roots, you ain't going to find them. You can have 2 imaginary roots that'll end up right on the end. So it's 4 positives, there's no negatives. So we have to look at doing the positive roots. Now we know it doesn't, so 1 is not a root, 1 is gone because it didn't add up to 0. So now we have to try a 2. So 2 synthetic division into 16, negative 52, 48, negative 17, and 2. So bring down your 16, multiply, 32, negative 20, multiply, negative 40, add 8, multiply, 16, add negative 1, multiply, negative 2. So 2 is a root. So we found 1 root. Now we have a depressed equation, which is Now remember, there's no positives. Sorry, there's no negatives, so they're all positive. So we found 1 is not a root. We found 2. So let's go over here, or we can go over here or here, don't make any difference. So now I'm going to try the next one, which is 1/2, into this depressed equation. So 16, negative 20, 8, and negative 1. So now, remember, there's no negative, so I'm checking these in order. There's no 1 because it doesn't add up to 0. We checked the 2, and we got a 0. So we got a 2 as a root. So now we're checking the half. Bring down to 16, multiply. 8, add, negative 12. Multiply, negative 6. Add, 2. Multiply, 1. Oh, we have another. Remainder is 0. So a half is a root. So we have a depressed equation of 16x squared plus 12. Oops, almost made that error. Minus 12. That's a minus there. Why I called it a plus, I don't know. Just one of those errors. Got to be careful. There it is. So notice that this is x to the 4th. This was x cubed. This is x squared. Down to the quadratic because we found 2 roots. There's 2 left. So we'll take a 2 out. 2 is a GCF. So take 2 out. We get an 8x squared minus 6x minus 1 equals 0. So if we take the 2 out, or we divide by 2, then we get 8x squared minus 6x plus 1 equals 0. It's not the 2 we're worried about. The root is in here. So a is 8. A is negative 6. Or can we factor this? B is negative 6. C is 1. So we can try to factor or do the quadratic formula. So we can do it either way. Let's try to see if we can factor. Factor. Let's see. We factor. The product is A times C, which is 8. The sum is B, which is negative 6. So the factors of 8 are 1 and 8, 4 and 2. So it looks like 1 and 8 is not going to do it. And it has to be a negative 4 times negative 2. The product is positive, sum is negative. So multiply these two, and you get 8. Add these two, you get negative 6. So it's 8x minus 4x minus 2x plus 1 equals 0. Take out the 4x, and you get a 2x minus 1. And the negative is here, so you take out a negative 1. That gives us, it's a negative there, negative x squared minus 1. Remember, when you divide by a negative, that changes to a positive, that changes to a negative. And again, 2x minus 1 is common, so you get 4x minus 1 left. And so we get 2x minus 1 is equal to 0, or 4x minus 1 is equal to 0. 2x is equal to 1, divide by 2. X is equal to a half. 4x equals 1, divide by 4. So x is equal to 1/4. So the roots are, we found out to be a 2. We found half, and we got 2 halves, another one here, and a quarter. So 2 half, because the remainder is 0. When we factor this, we got another half and 1/4. Now you could have solved this one by the quadratic formula and got these answers. But I'll just try that just for a bit of fun. So A is 8, so x is equal to negative b plus or minus b squared minus 4ac all over 2a. So b is negative 6, so it's the negative of a negative 6 plus or minus negative 6 squared minus 4 times 8 times 1 all over 2 times a, which is 8. So that's 6 plus or minus. And what does this become? I'll work it out up here. That's a 36. And that's a 4 times 8 times 1 negative, so it's 32. That's the square root of 4. So the square root of 4 is a 2 over 16. So now I got a choice. I can go 6 plus 2 over 16 or 6 minus 2 over 16. So that's 8 over 16, which is 1/2. And we got 4 over 16, which is 1/4. So you can factor it like this, or you can do the quadratic formula. And right here, if you wanted to, you could have said 6 over 16 plus 6 over, you could say 6 plus 2 over 16, or 6 minus 2 over 16. That's what I did here. Well, what I was going to show you, I didn't. I could have said 6 over 16 plus 2 over 16, or 6 over 16 minus 2 over 16, and I would have ended up with 8 over 16 right here, and 4 over 16, so either or. But what I do, when this root works out to be a perfect square, I go 6 plus 2 over the number, and 6 minus 2 over the number, and it makes it easier. So when this works out to be a perfect number, then add them together over the denominator, subtract them over the denominator, and it works out perfect. So that's more practice on solving these polynomial equations when you're using synthetic division, Descartes' rule, etc., etc., etc. I have my pattern. Hopefully it makes sense that you understand what the pattern is. But you can solve them whatever way. Sometimes they become easy, sometimes they become tough. So Descartes' rule helps me. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.